Question number 10. Two balls of masses m and 2m are traveling in a vacuum with initial velocities 2v and v. 2v and v. Okay. Collide with the head-on respectively as shown. Okay. After the collision, the ball of mass m rebounds to the left with velocity v of mass m. Mass m goes back with the velocity v. Okay. What is the loss of kinetic energy in the collision? So towards it, what we need to do is we need to do something like this. First, apply COM. COM, because conservation of momentum is applicable everywhere, right? Okay, so therefore now we have 2m into v minus 2m into v. This is the total momenta before collision. Should now be equal to, when it comes back, this should be minus m into v, and then this one 2m, the mass 2m might go like this with a velocity v dash plus 2m into v dash. Okay, we do not know. Maybe it goes like this, maybe it comes like this, doesn't matter. But we'll assume that it's going like this over here. So this is 2m over here. Okay, so therefore this goes away, but this should be conserved. So therefore I can now write, solving this, I get v dash is equal to v by 2. What does it mean? That means the velocity of 2m after collision is equal to so much. Now let us find out initial kinetic energy. What is initial kinetic energy? Half m into 4v square plus half into 2m into v square. Momentum before collision, the energy before collision. Then what is energy after collision? Energy after collision once again is half m into, what is the velocity of this one? V square plus what is the energy of this one here? This should be half into 2m into, with what speed it goes? It goes with the speed of v dash. What is v dash? V by 2. It should be v square by 4. We have substituted all of them. Now what do we have? We have to equate these two. Sorry, we cannot equate. We have to find out the difference. Ideally it should be equal. Okay, but if you find some difference, that means some energy has been lost, right? So therefore now let us calculate what is this value of EI. EI is equal to 2 1s are, 2 2s are, 2 1s are, 2 2s are. This should be 2 mv square plus mv square, which should be 3 mv square. Then E final, what is E final here? Half mv square plus 2 2 goes away, half mv square by 4. Half mv square plus half also goes away, right? Half, no, it's no half over here. Mv square divided by 4, right? So which should now be equal to half plus 1 by 4 into mv square, which should be 3 mv square divided by 4. Okay, this is what we get. Now what is that I need? Loss in energy. What is loss in energy? Delta E. Delta E is equal to E final minus E initial. What is it now? 3 mv square divided by 4 minus, what is E initial? E initial is here, 3 mv square. 3 mv square, which should now be equal to 4 3s are 12. Take the LCM. 3 minus 12 into mv square by 4. How much is it? 3 minus 12? This should be 9 mv square by 4. Of course, you can always say it's a negative value, but negative sign tells you it's an energy loss. So E final minus initial is negative, which means it's an energy loss. So take the magnitude here. It is 9 by 4 mv square. C is the right answer.